All right, this next region looks really, really hairy, but if you just follow every little step by step of our process that we've learned, it just works out so beautifully. All right, so let's have a look at this one. If we have a look at the left-hand side, okay, so this little piece over here, we're looking for a complex number which has a region where the modulus of z is greater than 2 and the modulus of z is less than or equal to 4. And that is intersecting, this is the intersection sign, it means and, all right? So as well as another region where the argument of z goes between negative pi on 3 and 2 pi on 3. All right, let's have a look at what we can do with that. Now, at the moment, I don't really know what these look like. I know my argument of z is going to be a ray, so I've got 2 rays there, but this one on the left-hand side, well, my suspicions are that it's a circle, but let's have a look at what we've got. Okay, so we're going to say, let's have a look at the left-hand side first. So z, 2 less than my mod of z less than or equal to 4. And I'm going to follow my process that lets z equal x plus yi. All right, so I've got that 2 less than x plus yi, the modulus of that, less than or equal to 4. Now, we know that the modulus of x plus yi is actually the square root of x squared plus y squared. So 2 less than the square root of x squared plus y squared, which is less than or equal to 4. I can square all of my terms in my inequality so that I've got 2 squared less than x squared plus y squared less than or equal to 4 squared. Now, I can treat each of these inequalities as 2 separate equations. So I can say, therefore, what I have is I have one of them that says x squared plus y squared must be greater than 4. So if I read it from here going left, I could also read from here going right, and that one says x squared plus y squared must be less than or equal to 16. Now, this is just 2 circles. Okay, and I'm going to be coloring in the area outside of this circle and the area inside of this circle. So I'm actually coloring in the area in between. And I can illustrate that with 2 circles. However, we're going to get to it when we're actually sketching the thing. But basically what we've got is, imagine that this circle over here is my x squared plus y squared is greater than 4. And this circle over here, or that's equal to 4, sorry, equals 4. And this circle here is my x squared plus y squared equals 16. My region that's greater than 4 and less than 16 happens to be this region in between. Okay, because it's greater than 4, I should have drawn the inside circle with a dotted line, but we'll get to that when we actually do our final thing. All right, now let's have a look at the right-hand side of this thing. So now we're going to have a look at z is pi on 3, the argument of z 2 pi on 3. So again, it's in the form argument of z minus alpha equals theta. And the important thing there is that we know that this alpha is our starting point. Okay, so therefore my starting point for my ray is going to be at 0, 0, and it's not inclusive. And I've got 2 rays at 2 different angles. Okay, so 2 rays, because I've got the argument of z is greater than or equal to pi on 2. I'm reading it from that side. And I've got the argument of z must be less than or equal to 2 pi on 3 if I read it in that direction. All right. So what I've actually got, if I just do a quick little sketch of it, is I have a ray starting at 0, 0 at an angle of pi on 2. Oh, sorry, pi on 3, not pi on 2. I wrote it down wrong. I was thinking it looks a bit funny. Pi on 3 and pi on 3. Okay, so I've got an angle here of pi on 3 and less than or equal to, greater than or equal to, solid line, and then another one at 2 pi on 3. So this angle is my pi on 3. This angle is my 2 pi on 3, and I'm interested in this region between the two. Now, because there's an and sign over here, I need to put these 2 pictures together onto my Argand diagram. Okay, and I didn't do this in advance, but let's quickly do our imaginary and real axes. So there's my real axis, there's my imaginary axis. Okay, so my first one, x squared plus y squared equals 4. It must be greater than, so let's do our dotted lines, and I need to probably decide what my values are going to be on my rings. So let's make my radii. I've got a 2 there. So if we go up in 2s, 2, 4, I think that'll work. Radius is 2, radius is 4. Do I want to make it a little bit bigger? Let's make it a little bit bigger. 1, 2, 3. That'll work for us. All right. So let's sketch our first one. So with a dotted line, because it is greater than. So there's my first circle. All right. And my second circle is going to be less than, and my radius is 4. So it's on this circle over here. Okay, and then I need to put my 2 rays in. So I know all of these divisions are pi on 12s, so that my pi on 3 is going to be here at 4 pi on 12, and not included. So there's my ray. And then I've got a 2 pi on 3, which is going to be at 8 pi on 12. So 4, 5, 6, 7, 8. That's over there at 8 pi on 12. And now all I need to do is color in the region where all 4 of these things overlap. Okay, so I'm looking for greater than my circle over here, okay, and less than this circle over here, and between those 2 rays. So all I'm coloring in is that little region over there.